Hello everyone and welcome to another live stream. And today, Blender is here. However, the main thing on the Blender it will be... Oh, the camera is back. That means it must be... hold on, give me a second, I need to drink some coffee. Okay, it smells really good, but tastes like absolute shit. Hi there Adrian, hi there Buff, hi there Average Blue, hi there Olo, hi. So everyone, hi there. Did the cable for Jesse arrive already? No. The answer is no. But I cannot stifle my inventive spirit any longer. It is not in my nature. So let me just bring out something. This seems fine. Hi there, Kazi. How you doing?
Meow.
This seems fine. What else will be there? What else am I gonna bring up? I'm also going to bring up... I chucked all of my parts into my drawer and now I just can't find a thing. These, that's also what I'm going to bring up. And then finally, what I'm going to bring up, one last part, is... That'll take me a bit to find. Okay, I might not actually even be able to find it because there is so much shit in my... I have a micro SD card reader even. How many things do I have? That's wacky, really wacky. Hold on, I need to find the... No, that's Raspberry Pi Zero. Okay, I can't seem to find the one last component I need. That's not good. Whiskey coffee is back. Yes. This live stream is sponsored by Day Drinking. Head of Dev Jesse, then the... Oh, is it only coma? Well, so far it is coma, but we're really close to pulling the plug. Because I've ordered a new plug, and if that plug doesn't work, then we're just gonna pull it because fucking hell. No, I don't. Well, I mean, I'm still gonna hold on to Jesse for a really long time, hoping to find a solution. But that will be on a matter of, that will be on a scale of months. This technically has what I want, I think. Oh, give me a second. I just realized my windows are open. That's gonna be so loud later on the live stream when some random bloke just... Oh, that's so much better. Yeah, when some random bloke decides to just rev their V8 for absolutely no reason. This is a box of snacks, like a Chex Mix of just different integrated circuits that I've bought.
That is wonderful.
The necromancer is on his way. Yeah, I don't let things around me die, you see. They... Listen, only in death does the servitude end, and even then, good fucking luck. Okay, so, these, by the way, I should probably explain. Why is Teto there? Today we're joined by Kazane Teto! Oh, this is like
I
absolute...
can confirm I'm literally Teto.
Oh, that tastes like absolute garbage. Fucking hell. I bought some coffee, I was on a discount. It was like a caramel latte or something. It sounded very fancy and it was on a discount, it was cheaper than my usual picks. But it doesn't taste like caramel, that tastes like... That tastes like caramel, if caramel died. It's like a rotting essence of caramel. Ugh. Anyway, I did order a separate component, like a tiny integrated circuit.
You know why I was on discount now?
Yeah. I did order a separate component that was an integrated circuit, a tiny lovely integrated circuit, which was just an audio amplifier, but I can't find it, so we're gonna use this one, because in my Chex Mix of integrated circuits, I also have this right here.
Already use it.
It's somewhere in my drawer. I don't want to just look for it right now. It's gonna take too much time. This right here is an LM386N1. That's what I call it. This is a nickname, and it's an audio amplifier.
That's a really...
Really what?
really mesmerizing nickname.
Yeah, it really sticks in your head, doesn't it?
Really gets your
Re-
horses going.
Like really catchy, really catchy. Anyway,
Yeah.
so what is this chip for? Well, you see, these are speakers, which I've also ordered. I'm a shopaholic, but I got some speakers, and the basic idea would be, obviously, in the end, to take my mask, right, and plop them in to create effectively headphones. However, the problem with speakers is that either this little bugger or the other little bugger, which is the Raspberry Pi Zero, so either this little bugger or this little bugger, one of these little buggers, will be responsible for moving audio to these speakers. The problem is, neither this little bugger nor this little bugger has enough juice to actually create sound. So, as far as I'm aware, this is my educated guesstimate, audio amplifiers are used in order to take just a little bit of controlling voltage and amplify it to actually drive a speaker. Now, what is the difference between an audio amplifier and a motor driver and a current regulator? Beats me! They all seem like they're doing the exact same thing, but they have different names, so I'm gonna guess they are different in some way, shape, or form. Anyway, let's do the thing that we always do. Yeah, okay. So, it's going to be LM386 data sheets. Give me. Okay. Battery, don't care so far. For now, all we want is gain. Input, ground, bypass, VS, V out. Okay, so this is the gain. Oh, because they can regulate the loudness as well. What? Clever. Wait, how do you regulate? Oh no, we're gonna have to do data types again, won't we? Alright. Inverting. Oh no. That's what I get from downloading audio. I did also order an oscilloscope. And if I, to be fair, the entire audio business of dealing with audio would be much easier if I had an oscilloscope. So, but it's gonna arrive soon enough. And when it does, then that's gonna make our job way easier.
What does it do?
Oscilloscope, basically, you know what a multimeter is?
Yes.
Yeah, so multimeter is used for like measuring all the, let's just say, electricity related values of circuits, right? Oscilloscopes are used for measuring wave related values. So when you have audio, for example, and then you plug in a speaker to power.
Also, it tells you like the frequency, the amplitude.
Yeah, that's a rough idea. There's some more to it, but well, that's where the oscilloscope, the oscillo comes from. You can basically see like the signal. You can see what the signal looks like. You get like a nice graph of what it looks like, which is really nice because when you are sending data, then you don't actually care about stuff like voltage or amperage. You don't care about those sort of things. What you actually care about is what the wave looks like, so that you can see what kind of data you're sending over. I'm waiting for the components to make a battery pack of a dead. Vacuuming the robot into a power bank. I mean, hear me out. A power supply unit will be a fun thing to make. I do believe so. The main thing holding back is the cost. However, we will get around to it. You make a new Maker team which produces pictures on oscilloscope. I do believe all Maker themes produce pictures on oscilloscopes, unless you mean like a picture that's not just a wave. I don't think that would sound very nice. Let me see. Okay, so power amplifier designed for user low voltage consumer application. Yeah, this set to 20 kHz by addition. The inputs are ground reference, while the output automatically biases to 1/2 display voltage. Using power drains only 24 milliwatts when operating from a 6 voltage supply. Preferred for battery operation. Well, I mean that's good. Okay. Down we go. Pin configuration and function. Could I get something that's a tad more verbose? Because not gonna lie, that's not much. Gain setting pin. How do you set the gain? Input, inverting input. What is the difference between inverting input and non-inverting input? Around, okay, for that I do not need really much of an explanation. Output, I guess, is gain setting pins. Power supply voltage bypass decoupling path. Right. Okay, could I please has a datasheet that's a tad more verbose, like for dummies kind of verbose? That would be nice. Okay, sweet, lovely. Once again, we have all the pins named, and then as we go down, move this amplifier. Two pins are provided for gain control. With pins 1 and 8, open the resistors and set gain. If capacitor is put from pin 1 to 8, the gain will go up to 46 decibels. Oh, potentiometer! Oh my goodness! I still didn't pick up my ceramic capacitors. That would be really convenient right now. Oh, that's clever, potentiometer. Right, I should have one somewhere. Somewhere in my 70,000 boxes and different electronic components, there should be a single potentiometer, because I refuse. Well, I mean, we don't have to use that. We could technically use this, I suppose. This would do the trick. This is a magnetic field detector, as far as I'm aware, which means I could I
So
could
like a compass.
I feel like it's more. I'm guessing it's like we put a magnet to it, or a battery, or a circuit or something. I haven't got a clue. Haven't tested. Haven't tried it once. But basically, normally what you would have here is. So let me bring it over here so you can see it better. Normally, what you would have then, I imagine, is a coupling capacitor, right, to regulate it, and then I imagine potentiometer in order to regulate the resistance. We would change the gain, so we'd have like a diode that we would switch on and on, so you know, so you would change the.
Putting magnets around electronic components usually fucks them up.
Well, it doesn't have to be a strong one in this case. So this is what you would normally have. However, in my case, I could just use this. Like, that would be so funny, where I just, if I if I want it to be louder, I just bring in a magnet closer to. That's so dumb. Hold on. Let me see. I should have a. I also have a microphone, which I could also use for this, which means that you would need to yell in order for it to get louder, and then once it gets louder, that would self-feedback loop.
Like a metal plug with a word louder written on it.
Yell.
And as you move it towards the mouth, it gets louder.
Yell for loud. What else? Do I know? I definitely have a potentiometer somewhere. I refuse to believe I don't. That'd be so silly if I didn't. I need to declutter my thing, bring up more of these boxes that I use on a daily basis. Because M2 screws, for example, that I do use really often. I also use the wires really often. I also use these wires really often. No, that's a switch, that's not a. I guess we'll need to do the constant gain then. We won't be able to change the gain for now. Oh, I found the thing I was looking for. Right here in my baggie of goodies. Well, let me turn off the screen. I have a baggie of goodies. And in that baggie of goodies, there is a bunch of multiplexers. These.
Are they edible?
It depends how committed you are, I suppose. These are multiplexers. my bag of edibles. And then this is an audio amplifier I got. And it's a bit chunkier, but it looks to be a tad bit easier to operate, I imagine. Yeah, because you have left plus and minus at the top. You have right plus and minus at the top. At the bottom you have 5 volts minus and plus in this corner, so that's the power. And then LGR, which I imagine is ground, left control, right control? No, nothing like guessing. Okay, can I look this up as well? That would just be as well help. I would prefer like a really tiny bit of a PCB into it because it seems to be made for easy operation. HW104. What do you have for me in store? There! Military that's not what I'm looking for. This is what I'm looking for. Data sheets. Yes! Splendid, beautiful. Okay. That does not look anything like my... My thing has like 1, 2, 3, 4, 5, 16 pins. This one has 4. I am skeptical. That's A. That's probably because it's A, isn't it? Wait, is it only... Yeah, okay, I guessed correctly. These are outputs, this is power supply. Well, I guessed. I guessed. The letters are right there on it. Which means we can try it. We would need to probably solder them all correctly in order for this to work. Which means I imagine we'd need to solder the speaker to one of them at least. Then plug in the power. I would rather do it with jumper cables. The problem is that these are not right pins for jumper cables. I would need to solder the pins onto a
soldering stream.
It might be another soldering stream. That's not a bad stream, is it?
Time to spray last acid and lead in your face.
I do that without even the soldering stream. I do that for fun. Okay. I got a couple of...
You do many questionable things for fun.
I'm bored. Okay?
Come on, God, just kill me already. I'm bored.
This is an important USB cable, because this USB cable is for the Raspberry Pi. Now, here's the thing about the Raspberry Pi. We should probably first, what we should do is we should take a buzzer. That's because it's much easier to test sound with a buzzer than it is with a speaker. Because for the speaker, as always, we want to reduce the amount of points of failure as much as possible to make sure that the thing we're testing is actually being tested. And we're not getting garbage problems from all the parts. I do have a tiny speaker as well, which could function well for testing. This tiny little thing. We could also plug it into our Raspberry and see what we get. And if we get... Oh, plugging this in will be a bitch though. Yes. Okay. Anyway, everyone, how are you all doing? Because I've recorded at the beginning of the stream, and that's because I wanted to introduce what we'll be doing today. Also, the camera is a bit skewed. Let me just... Oh, yeah, now it's in the menu. Much proper. Much more proper.
Nice.
Right, well, let's actually have a think for once in my entire life. I'm doing okay. The weather is just like absolute dog shit. What kind of dog shit weather? I'm guessing it's hot, isn't it? That's kind of dog shit. How are you? Me? I'm okay. I'm okay. We're gonna test this. If it works, then that will be fine. I have a shit ton of work to do today, however, fortunately. Because I'm really behind as always. Oh, it's pissing. Oh, raining! Rain is nice.
Of course you would say that.
I like rain. I would be happy if it would be hot. Well, then you're lucky, because I'm here. If I had a nickel for every single time someone said that to me. Okay. I would be happy if it was hot.
Yeah, I'll be happy with you too.
I think I need to cut this open. I too wish it was raining here. See?
It's been surprisingly not that hot this summer yet. Honestly.
My dress code is either straight up black or really, really dark shirts. And I don't wear t-shirts, so I am glad with it not being hot.
Yeah.
If you all think that y'all have it tough when it gets hot, just quick reminder, I do wear black shirts all the time. I don't really have an alternative wardrobe choice. The mask compels me to do so. That's why I look like an absolute sociopath when I walk around the forest, because I'm like fully dressed. Just wear no shirt. No, I become too attractive then, unfortunately. It's a real shame. Once again, I've been cursed by a witch. Keep insulting them. Okay.
Cursed by being too hot.
Yes, that's my curse. I'm too hot. Oh, darn you witches. Okay, we're gonna plug this into...
You make all the men around you gay.
That is not the right Raspberry Pi. It just hit me. That's not the one I've been using. That's a different Raspberry Pi. It just, yeah, because this one is a W. I didn't do it with a W last time. Shit, where am I gonna go? This to projects, surgery. Yeah, don't save there. And then we're gonna have waiting for board to connect. Well, pardon me, but it sure as heck looks like it's connected. The last device you connected to this computer malfunctioned. Well, that's great. Ryan Gosling. No, that should be an equality. The equivalence. This Raspberry isn't really connecting. I think as I realized that it's not the one we've been using. This is the one we've been using. See, it's totally different. Okay, so let's just replug everything. Well, we probably won't be using this yet, so. Why did I plug this backwards as well? Because now I need to have the USB cable go over like this. It's idiotic. Over the brain, whatever. So, we take the ground, which is... Let's be reasonable. Ground. Perfect. And we plug it into the ground of our tiny speaker. This cable is just not closing their mouth. Alright, fine, we're doing it the yellow one. The yapper. I do think it's kind of cute how we call the speakers, you know? It's like, oh, he speaks. It speaks!
What do you want to call them? Yappers?
No, they're like, you know, it's... Because microphones we call microphones. We don't call them listeners. But for speakers we actually go with the speaker. It's speaking.
Microphone is a stupid name, no? Why is it called a microphone?
Well, it's because it's small, idiot.
A small phone, yes. Very good name.
Right. Let's place it there. And now I'm gonna plug it into the 0 pin. See if we get anywhere with this. Alright. As always, from machine imports pin and also PWM. PWM pin 0. I'm just doing it from memory. PWM. I didn't realize it was good. PWM dot duty U16. Let's set it up to be half. Yes, so 512. And then let's set frequency to be 500. Can you hear that? I don't think you can you? Now you probably might be able to. It'd be buzzing. Okay, great. Testing successful.
Okay.
Yes, splendid. You can stop now. Alrighty. It'd be buzzing, it'd be buzzing. I don't know what could have gone wrong in this, but I'm still glad we tested it. Nonetheless, just in case. Now what? The highest temperature recorded in Poland is 37.4. Yeah, maybe sounds about right. Is it 37, really? I vaguely remembered reaching 40, but I could be schizophrenic, so... Alright, so that was the...
40. That sounds low.
That was the little cheesy bugger. Now it's time for the big boy cheesy bugger. Now the big boy cheesy bugger will not work in the same way. That's because if we just plug it in, like this, to the signal, and red to the ground because I have no morals.
Tefta.
Tefta, hi! How you doing?
Hey, what's up?
I'm doing audio without an oscilloscope. Because it hasn't arrived yet. It's a great idea, I know.
No, I mean the sampling rate, 240 megahertz, right? Is the clock speed? Or what is the clock speed?
Okay, let me
Let me
see.
see 50.
Pin, and then PWM.
Two.
Yeah, you can't hear anything right now, even though it should be playing. And the reason why you can't hear anything is because, you know, it's a big speaker. And Pico has no right to power it just by sending the signal. This is why
Do you have an
I have,
N-channel MOSFET?
well, I have an audio amplifier.
Oh,
Yeah, convenient, right? yeah. That's kind of, well, I have a couple of them. I even have. Remember my big box of random? There we go. Big box of random integrated circuits.
Yeah.
Yeah. Apparently there are a bunch of audio stuff in there. There's so many audio. Like there are 3 different audio amplifiers. But I'm,
awesome.
yeah, but I'm not gonna use any of them because I got a specific different one right here. Because I was really interested in it, and it appears to be fairly easy to use. It comes with a PCB board, which I really like, because all of the resistors, coupling capacitors, and such are already included. And I love that. Which means all I need to do is just connect it properly, and hopefully it should function. So, we plug in the plus to the right channel plus. Once, as always, I am avoiding soldering with all my might.
Smart.
Yeah, simply because it's not great for these kind of PCBs, but poor Pico, I mean, it was trying its best. I need to I really should get some smaller jump cables for this. And we might
Yeah,
need to
they
solder
sell
it.
these. They sell these like clip-on things that are meant for clipping onto individual pins from surface mounted.
Yeah, I mean, in this case, it's not even super surface mounted. It has, I don't know if you can see it. Like on the corners. Actually, wait, why am I doing this? I have a
Yeah.
picture right here when I was looking up the data sheet. There we go. Like on the corners, it has normal pins. It's just that my jump cable is still too big. Alright, we might need to solder it. I just unplugged the random plug from my wall. I don't know what this is for actually. Ah, whatever. I'm plugging my soldering iron.
But you can also use a N-channel MOSFET for this too.
I know, but the thing is, I have two of these actually. And this one already has left and right control. And it has a. I actually started the stream by saying that I don't know what's the difference between amperage regulators, motor drivers, and audio amplifiers. I do not know what the difference between them is. But since engineers call different components different things, I'm assuming there is some kind of difference. I have
Yeah.
no clue.
Well, I think right, audio is an AC wave.
Also, like this.
So because you're gonna have to go
Oh,
plus
so
and negative
audio
volt.
amplifier is like a
Yeah.
motor driver combined with a transformer.
Yeah, and it's for specific frequencies, right? Because you're only looking for 20 hertz to
That
20,000
makes
hertz.
sense. That does make sense.
But you're essentially just using pulse width modulation. So you're kind of like, because you're not using the DAC, I'm assuming, on the Raspberry Pi Pico, are you? You
DAC?
just use digital to analog converter.
No, I mean I'm using PWM for this. Yeah.
Yeah. So yeah, since you're using PWM, you're only using half of the, the positive side of the. But what's interesting, right, is the motor also will generate electricity because it's generating an AC wave. If you're sending it PWM, it's going to be generating electricity on the downstroke. Because as you're pushing the cone out, when the cone is
Yeah, that's why
pushed back.
even if I don't know exactly what the difference is, I still prefer using specific components because there's always going to be something that I didn't think of, but that the engineers did.
It might protect your Pico more.
Exactly. Hence why motor drivers to drive the motors.
Yeah.
Or break it
Always
faster.
just protection.
Break it faster. I still love the tiny ones. They're great. Okay, we'll need to. Okay, what we will need to do is we'll need to solder the component. Let me just. I'm already making a huge mess on my desk for absolutely no reason. I'm glad I cleaned up my entire apartment just to trash it the day after. That's why I don't clean. I cleaned up my apartment and my Jesse died. That's what happens. That's why you should never clean up your workstations. Okay. So what do I need? Well, I need the. I don't want to solder it permanently. This is all effectively still temporary. This is meant to be just like a temporary extender to make testing easier. So we don't need anything too glamorous, too elaborate. We can just use the tiny wires. Alright. I'm going to use two gray ones of the same exact color because I know that everyone hates it when I use cables of the same exact color for opposite things.
Are we using our good old friends diode pins?
No. The diode pins are surprisingly great for soldering. This is really small. I might be building some model ships later. Oh, that sounds lovely. Do you like buy a model or are you gonna design a model and build it? one. I've gotten so much better at soldering. Considering how much solder I had to apply back in the day in order to get anything done. Like, it's not like I'm amazing now, it's just that back in the day I was shit.
Mm. Okay.
So I'm reading the data sheet for that device, that integrated circuit, and it's like, don't do this or it will be damaged. Don't do this or it will be damaged.
Yeah, that's why I'm using the one that already has a board around it instead of just the
Yeah.
integrated circuit one.
It's saying it needs
yeah.
5 volts. You can't give it 6 volts or it might damage.
You would not be able to fucking solder anything onto like just the circuit. That one's way too small.
Ow, 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 ow. Stop.
Can you not?
Go. I'm only lightly burning myself, don't worry. Okay, so that was the right channel, which means that if that was the right
Okay.
channel, we also need the...
You said you're better.
Yes.
Are you any better on fucking hurting yourself? Doing the thing?
Nope. Round pin, then we'll need the signal on the... signal on the right pin.
Yes, Adrian, that is exactly what he said.
Then you can quote me on that. Round pin. Yes, I don't think it should be. Right, perfect. And then finally a signal for the right pin. Maybe soldering in the dark is a bad idea. Yeah, but I don't have any light. I've run out. I do have an LED strip that I really wanted to mount like on the top of my, like right here, on the top of my workstation that would be lighting down. But the problem is I first need to build like a nice structure for it. It's just a massive chore. We will probably get around to it eventually. I just need my free printer. Okay. That's them. Now the power supply, we need 5 volts. Of course we do. So let me just... Shit! I mean, shucks. Okay. Yep. How much? $620, of course. This, okay. Unfortunate. What if I take out the battery and just connect the two of them together? That could work. Easier said than done. It could work.
Yeah, it's funny. The data sheet's like, the recommended operating voltage is 5.5 volts, but when the PAM 8403 is powered by 4 battery cells, it should be noted that the voltage of 4 new dry alkaline batteries is above 6 volts, higher than its operating voltage, which will probably damage the device. Therefore, it's recommended to use 4 nickel metal hydride rechargeable batteries or 3 dry alkaline batteries.
I am so glad that they idiot-proof the datasheets like that. Do keep in mind, because that's what I'm using, right? Like,
Yeah, yeah.
I mean, I tested it, but it's a coin flip on whether I would test 6 volts or not. So I'm really glad they idiot-proofed it. On the account of all of my fellow idiots. I appreciate. Okay. What is it
My
now?
fellow idiots.
Twin Peak. It's 4 points. 4.64. Do we call this close enough? Let's see. What's your name? What is your name? Well, that's the A again. I don't know.
It should be. Oh, you're looking up the HW104A. I just looked up the PAM 8403.
How did you know it was PAM 8403?
Because that's the chip that.
Yeah, I mean, I figured that. It's written on the chip, but how did you know that was a chip?
Because the other markings, whatever it was, like H whatever, that will take you to the actual chip name.
Oh,
PAM
okay.
8403.
No, I just
Yeah.
read the chip and I thought you were a wizard or something and could actually see it through the camera.
No. I just do a lot of troubleshooting, and I'm like, okay, I need to know what chip I'm looking at. Yeah, that's the part, section 3 in that page.
Wait, parts
Don't
exchange
use
fee?
4 batteries.
Interesting. There we go. The recommended operating voltage is 5.5. That's recommended, so I can go below. A voltage of
Yes.
only running is 6, higher than the operating for the 4 is recommended is 4. Or 3 dry. Yeah, I did use 3, so that's good. To be fair, my power supply looks a bit. Make it, but it should be fine.
Looks great.
I like using make it as an adjective. Let me just hold this and then solder the minus to the minus, plus to the plus.
Adjective, verb, noun, everything.
You can use it for everything. That's the beauty.
Yeah.
Okay, I'll need to be holding it as I solder, which means we first need to apply some solder, like so. And then solder them correctly. Come on. That's the first one. Way too close. That's where I put my thumb. Way, way, way too close.
It's another one of those hard streams.
One must suffer in pursuit of science. Sacrifice must be made.
You will dip your balls in sulfuric acid.
There we have it. Beautiful.
You are technically welding, so.
in a way.
I'm soldering welding.
Well, it's because you know the solder stuff is a metal.
Isn't it always a metal?
Yeah. So essentially, every time you solder, you're actually welding. Just really small welds.
In a very silly way as well, because normally
I don't like that.
you don't turn anything into a liquid when welding exactly. Well, at least for that kind of period of time. I don't like how much they're moving because that leads me to believe it's not soldered properly, but oh well. Oh weld even. This now.
Oh well.
Oh weld indeed. It did glitch a bit when I connected it. That's a good sign. Electricity. I really want you all to see my set because it's so wacky looking. It looks. I love the look of prototyping with jumper cables. Prototyping without breadboards, it always looks so silly. What do I need now? Well, now I need to connect the ground to ground, and then I need to connect the right to PWM. Honestly, I'm guessing I didn't check if there's PWM, but I feel like that's a really safe bet to make.
Yep. PWM.
Fudge. It is cracking as I move it around. Can I just really quickly unplug it from the breadboard? That would make my life so much easier. Ah! Yeah, I dropped it. Okay, there we go. So, I could actually use the other type of jump cable, which in this case would be a bit better. And so what we do is we do yellow, green, blue, which means blue is the ground, yellow is the signal. Oh, how convenient! That is the standard. Okay. Green, blue is the ground. This. Oh, there's already some sounds happening. Which means we've got noise in our system, which is actually, on one hand, really good because it means it's working in a way. On the other hand, really, really bad. Because
That's the sound of a single pulse. Probably.
PWM, PWM pin 0 and then pin 0. No, I'm an idiot. PWM. Holy shit! Ha ha ha! Mwah! Mwah! Beautiful! Tefta, when you prototype things, like, is that what it feels like? Where you test something and it works? Because I'm not used to it personally. I know that you would be, but I'm not. Usually there's like a 3-hour long period of me just messing about only to realize I haven't soldered the pin, so...
Yeah. It's magical. If it works, it's magical. It's like, I think this and this will do it. And then when it actually works, it's like, wow.
It's so hard to convey this in the video. It's so hard to convey in the video just like the surprise you get, and at the same time, like, it's so hard to convey what's difficult and what's easy. Because the thing is, if you think about it right now, it works. Obviously it works. I have an integrated circuit whose only job is to work. Integrated circuit which has been designed by professional engineers, tested by professional engineers, packaged by professional engineers. It even has a wrapper PCB. So like on paper, if there is someone who doesn't actually do engineering all that often, or doesn't prototype, doesn't do any of that stuff. Like, in order to explain what's difficult and what's easy, first you need to explain that this is actually conceptually really, really easy to do, because the entire thing is just handled by this integrated circuit, not by me. And then once you explain that, you need to then explain why you wouldn't expect it to work, despite all the reasoning why it should work. It's always the things that you don't expect that cause all the problems. It's really annoying. That's really good, actually. And what's even better is I can just unplug this cable right here, and now it's no longer powered. Which means I don't need to worry about ruining the integrated circuit by short-circuiting something due to faulty wiring, because if I disconnect this cable, now it's proper. It being supposed to work doesn't mean it should work. I mean, like, in an ideal circumstance, everything always works, but that's what I always say, so many points of failure. That's why we first tested with the mini buzzer, even though we didn't need to.
Yeah, because it's like maybe the chip actually needed a power on signal from a different pin that would do X, Y, Z. You know what I mean?
Yeah,
There could be
exactly.
1,000 things that go wrong.
Or in
even
my
though it seems
case,
like it would work.
we don't even need to go that far. Or in my case, it could just be, what if Make It just didn't solder the UART RX pin? You know, that also could be it. Hypothetically, of course. This is fun. Okay, I'll be brutally honest with you all. This is like all I wanted to do with this stream, hardware-wise. I do also have this, which is a microphone. But for the microphone, I didn't actually want to deal with it this stream. I wanted to leave that for the next stream, because next stream I was planning on just writing a driver for it. I've never written a driver in my life, but I do believe that when it comes to a microphone, that should be as easy as it gets. I can't really imagine a component that would be easier than this to write a driver for.
Is that an I2S microphone?
Let's hypothetically say I don't know what I2S means.
It's a different type of protocol like I2C, but I2S is for higher bandwidth things, such as microphones.
So the reason why I say it would be really easy is because it actually just has a single output pin, A.
Oh.
Yeah. Yeah, it's a very...
So you'll just sample. Interesting.
Yeah, exactly.
So yeah, you're going to be limited by the frequency of your ADC on the Raspberry Pi Pico.
Yeah, exactly. Well, this one I think I'll be writing on 0, not Pico. Simply because, well, I don't think I could do it on a Pico. But that's actually what's so interesting about it, because when it comes to I2S, I know what you're talking about, because I've seen there's one that's really similar to this microphone, except it has like 7 pins. And
yeah,
I guess that's the I2S one.
Well, that could be SPI. So like when it comes to audio, what's difficult about audio is your sampling rate, because in order to sample a frequency of 20,000 hertz, you need to at least be double that. So you need to sample it 40,000 times. Because you can imagine that if you sampled at the same frequency that a wave was, it's possible that you would only capture it as it's traversing the 0 of the scale. So
yeah.
it might look like there's nothing. Yeah.
Yeah, but
so you usually have to pipe the audio somewhere. So usually it's like SPI, you're going to pipe the audio directly into an SD card or something. Because if you're on a microcontroller, but if you're on the Raspberry Pi Zero, you could just write the memory.
That should be comfortable on the 0, because then I would be limited by the clock of the ADC pin.
Yeah, so the ADC is going to be a certain bit depth. Like, I was just looking that up on the Raspberry Pi. Because usually those ADCs are 12 bits. No, okay, so... yeah, these are 10, 12, or 16 bits. And then you have to see how fast you can sample it. So whatever the sampling rate, if it's below 40,000 samples per second, you're not going to be able to pick up the full range of audio. You're going to get like an old school microphone sound.
I'm sorry.
It's going to sound like you're recording a telephone.
Yeah. I'm curious, what is this maximum sampling rate on an ADC pin in the Raspberry Pi Zero? I should just read the documentation. It's gonna be somewhere buried in the documentation.
240 samples per second.
Wait, 240?
Yeah, so you're not going to
That
be
seems
able to
very
get.
low.
Yeah, so
Very,
you're only
very
going to be
low.
record sub 120 hertz. This is why audio devices are so expensive, because the ADCs they have to be very high quality, and DACs, right? Digital audio converter and ADC, analog to digital converter. So if you look at a mixer, like, and you buy an audio mixer, the reason why they're so expensive is they're usually rated at like 96 kilohertz, 44, 48, or 96 kilohertz. Plus the bit depth is usually 16 bits. So if you look up if you just want to buy an integrated circuit for an ADC that meets those specs, you're gonna see that they're expensive.
I do have an audio mixer I'm not using, which I could just scrap for parts. And I do have, well, it's still getting delivered by an oscilloscope on the way.
Awesome.
It turns out I wasn't able to buy the oscilloscope you recommended. Well, because I can't really buy things off Amazon. I've learned. It's just the thing that we're basically on Amazon due to recent events, like shipping from America. Just the mere fact that Amazon's America like jacks up the prices sometimes 200% for me.
Oh my goodness. What oscilloscope did you get?
I just go to like a more local version of Amazon, and let me just read you what I got,
Yeah.
because where's the
How many channels? Usually 2, and then what is the samples per second? Like 1 gigasamples per second or 0.5?
if my memory does me well, I'm not gonna answer my memory. I'm just gonna read it just in case I'm wrong. So it is 2 channels, 150 megahertz, and
Awesome.
where's the gigasamples?
It's probably 0.5.
If I remember, it
gigasamples
was
per second.
1 gigasample, but I don't know if I remember correctly.
That sounds right. 1 is good for right around that range.
Yeah, 1 gigasample.
That's awesome. I mean, that's everything you need.
It also
man.
says that it has a generator of 25 megahertz.
Yeah.
That's for sending, I imagine.
So, yeah, like you can test your probes by clipping on to that. It's usually 2 pieces of metal with holes in them. So that way you can actually calibrate your probes. And so there's a little like screw on each of your probes, and it's going to generate a square wave, and then you can adjust it to make it so that square wave is square.
Yeah.
And that's usually like a reference wave that comes with those.
AliExpress seems like a good spot for parts, no? Well, Blue, for parts, yes. However, I have some bad experience with buying equipment off AliExpress. Because, like, parts-wise, integrated circuits of AliExpress, mwah, mwah. Compliments to the chef, they're beautiful. My 150 motor drivers are genuinely probably the most bang for my buck purchase I've ever made. I love them. I love them with all my heart. However, when it comes to equipment, I wouldn't personally recommend. It's a bit of a hit miss. But yes, we got have an oscilloscope on the way, and a CNC machine, and a 3D printer. Oh,
CNC machine.
yeah, I did get a CNC machine. Yeah, like a small
Oh my
one.
goodness.
Yeah, a small one. Yeah. I thought it could just be useful with all the things. Like, for example, I've been trying to cut out a visor for my mask for a really long time. Let me just, this sort of thing. And I've just been shit at it. Really shit. And I imagine a CNC machine could help as well.
Oh yeah.
So I feel like a CNC machine could be a nice addition. Not even for PCB. I mean, I will probably still use it to make PCBs once in a blue moon. But not even just for PCB making, just in general, I feel like CNC could be... Wait, is the 3D printer coming today? I don't think so, no. It's when I bought it, it's at 3 to 10 days, so I have no clue. But yeah, now I'm gonna finally have more proper equipment. Well, in the meantime, because this is... I am being completely honest when I say that I thought this would take me an entire day. It's always difficult to explain, so difficult to explain when something works, why you would expect a lot more time for it to actually work. Because, well, nothing bad happened, but I genuinely thought this would take me an entire day. So I suppose we can get back to the other thing I was making, which is the quantum mechanics video, and at the same time also the workshop video. On day 5, nothing happened because we were just working on videos, and day 6 will be introduction to audio. We can also do some research later on writing drivers for Linux, and then we might not end up using this microphone if the ADC sampling rate turns out to be too much of a killer, but still looking up into how to make drivers still will be convenient because we will need it no matter what, just in case for the future reference.
Well, yeah, if you have, because the Raspberry Pi Zero has an audio input on it. And so if you were to find a DAC for the output, you'd probably need a driver that you could write for it. Or you can actually just purchase an I2C microphone and then write the I2C.
Yeah, that would probably be exactly. That would probably be that's probably what I'll do. I will probably need to buy something with a better sampling rate. But because okay, I am guesstimating here because as I mentioned, I've never wrote a driver, nor have I ever looked into the process of making a driver. But I'm guessing that Linux has some kind of way of handling audio internally, and the process of writing a driver is just a matter of connecting the internal processing of a data type to an external way of processing a data type. I don't know if I'm explaining what I mean really well. So basically, if we have paint. Why do I have paint open?
My eyes are already glazed over. Drivers sound tough.
I imagine it won't be too easy, but at first I'm gonna make a guesstimate to just check my knowledge, see how much I know about computer science. I imagine on Linux there will be some kind of internal data type for devices, so /dev sort of thing and then there will be some kind of way of creating a device there, and then what you need to do, so probably Linux will have a way of creating a device in /dev, and then it will have a way of sending data to that device, and what your job would be as a programmer is, I imagine, sending out data. SPI Linux character device driver. Sounds really close to what I'll be doing. Writing a generic kernel mode, remove information in this link, very useful. Pasting some working API. Yep. Header, beautiful. Well, so far, complaining. I can also ask Alu, because I know that Alu wrote a bunch of drivers. Which is probably what I'll end up doing. When the first caveman programmer chiseled the first program on the walls of the first cave computer, it was a program to paint this hello world in antelope pictures. Roman programming textbooks began with Salute Mundi program. I don't know what happens to people who break with this tradition, but I think it's safer not to find out. Oh, this is great. Okay. Most of these two functions: a start, init module, and a cleanup. This is very standard. This is so standard, in fact, to have an init module and a cleanup module that my graphical engine had in its own DLL handling I've set up. I've set it up with an init, run, and cleanup input functions. Well, not functions, modules. Each module had to have an init, a run, and a cleanup. And that was with me not even realizing that it's a standard. This is just such a logical conclusion to come to. Making a hello world program is necessity confirmed. That is true. The first thing that Fixit will do after you... the first functionality will be for Fixit to say hello world. Okay, makes sense. Logging for the cans for log information or give warnings. This is actually a very nice rabbit hole for me. That's something I'll need to get to if I want to actually utilize the Linux kernel. Macro. This is a good print of your console and just log into your log file. Okay. Can I build it without the make file? Just, it's not that I have anything about against the make, I just don't like it. Make it Linux switch incoming. What do you mean? What do you mean by a Linux switch? Your init cleanup function must be defined like, okay. So right here we don't have much of a change. I'm going to leave it be. I'm fine with init. Are you switching to Linux? Well, my mask is gonna be running on Linux. I am not gonna keep any module documentation. Yeah, no. 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 I make things that work. I don't make things which are useful. Important distinction. Why is your mask on Linux? It's because it's a good operating system for developing stuff. Really good developing system for that. Oh, we might not need that as a driver then. This is... Wait, if this is really how drivers work, then we might not need it as a driver. I take it back. Okay. I was incorrect. Apparently there is no internal handling of things like that. Oh, that's convenient. Well, I mean, double-edged sword, but... Because we'll need to get into audio processing a fair bit. Shouldn't be that difficult, because if I understand it correctly, then you just do samples on the sound, and each sample just represents the... You know what? I take it back. I don't understand it properly, because I don't know if it's a value or if it's a frequency that each sample represents. The point is we will need to do a deep dive into sound streaming in order to make this. Which, is it easier or harder than deep dive into drivers? I do not know. But it feels a bit better long term. Make it, did you also get pouring rain all of a sudden? I'm indoors. That's not usually where rain happens.
You know, it's funny is I'm actually working on a similar problem with audio, but I haven't spent the time required to figure it out.
Wait, what?
So I've been working with some audio just for some, you know, like machine learning stuff.
Yeah.
And I have some I2C, I2S microphones and amplifiers, and I've connected a SD card to my microcontroller, but I have not been able to get I2S working. So I just switched to Raspberry Pi Zero with a USB external microphone and headphones. About like a $10 adapter, and I was hoping to use that because I didn't want to write a driver. But I did successfully connect an SD card to my microcontroller, so I could technically record audio and play it back.
Well, that's a bit of a pickle. I'm not gonna lie, that scares me a bit because if you're having problems with it, then does not bode well for me.
Yeah, MicroPython using I2S is a little bit difficult. You're relying on people writing drivers. But if you're doing it on a Raspberry Pi Zero, it's not that difficult if you just use like an audio card. But yeah, if you're trying to do a hardware level capture, you run into so many throughput limitations of components.
Wait, use Wikipedia as a source? Yes, I do. I do use Wikipedia as a source. It's yet to fail me. Okay, so word select. Oh, right, makes sense. That's simple. And serial data. That is wacky. So with hardware components will be better. Oh, I'm gonna need to compile a list of things I'll need then. Yeah, then I do need an I2S microphone then.
Yeah, because it's going to be able to send the data fast enough to be read to record 20 to 20,000 hertz.
There are actually there's a whole roadmap of what things I need to do because I need to first I'll need to hardware-wise handle audio. That's gonna be rough. Then I mean I suppose I can connect the left and right channels not even to the Pico. I can connect them directly to the Zero. Because well the Pico is there as a multiplexer and I don't feel like for audio that's necessary. For audio, might as well go straight to the point.
So what are you trying to do with the audio?
I mean, it is really simple. Just microphone and two speakers. The speakers speakers are self-explanatory, and the microphone. I want the input from the microphone to go into the Zero. I want the Zero to then take that input and package it in some kind of nice way to send it to the Pi 5, and I want the Pi 5 to be running Fixit, which will, run it into speech to text, and then have that handle my AI. Which is, once again, it's silly because when I'll be mentioning in the video, all the most difficult parts of this, like all the most impressive parts of the project will be also the easiest ones. And all of the most difficult ones, I will need to explain why certain things are difficult first, before even explaining how I'm gonna make them. Okay, I'm going to... This standard was last revised on February 17, 2022. That is... Oh, Irish exit. Okay. On the previous two functions. So right here, let's just... by the way, I've made this. And we can first of all make this a bit more efficient. That's because if our size is equal to 0, so if this is math less than 0.01, I imagine, then yeah, and this will make it a bit more efficient because now all of the tiny things reputation of the source removed. I mean, yeah, I think Wikipedia has a really fine source, especially for all technical things. I feel like all the criticism of Wikipedia as a source comes from like a more social aspect, because you know it's really hard to like even in really rigorous reputation, it's still difficult to remove the bias. But when it comes to technical things, there is no downside to using Wikipedia. I haven't found it yet, at least. It's really great compiling. I'm still here. I know. It's just the Irish exit of from the voice channel always cracks me up. We need to normalize Irish exit some more, you know? Now right here what we want is we want 111 like this, and then we'd like, gee whiz, what would we like? We would like, hi the West and hi. We would like to take out the variables into their own separate objects. That's because it's a bit easier than handling like vertex groups. Was there really no C constant? I must have done something wrong. Where's the C constant? This is the C constant. We multiply the entire thing by a C constant. Whoops! Right here there should be a C. Oh, whatever. I'll take out the D as well. And then we can leave the P, I suppose, because the P, if I'm not mistaken, that is just the exponential of... Yeah, that's just making it more pronounced. We can leave that for now. So, first we'll have A change the emission color from this to the color of... Well, the color. What is the color? The color is right here. There we go. Have the A switch to that color, and then we want this to start like shining a bit more. Now, how are we gonna have it shine a bit more with the color in mind? This is A. Increase it. This is what happens. So I think is we should have a color ramp right here. That should go black, then it should go this. It does look a bit gross. It does look a fair bit close, but oh well, whatever, I'm leaving it. The point is we can change the underlying variables and then the function changes, which will be important when we get to the orbitals, because that's how orbitals in chemistry function. Okay, swell. In the meantime, can we work on anything for the workshop? Like data mechanics, for example. You will need a more proper microphone. Let me just look up real quick how much a simple... we need a small one as well, which I imagine, well, if they're modules, I'm guessing they're all small. I2S microphone. Yes. Oh, never mind, it's not bad. Not too bad. Okay. I do remember there was that connecting I2S microphones to a Raspberry Pi Zero is actually surprising of a standard. Or at least people have done it with Pi 5s and Pi 4s, which can carry over to Zero because there isn't much difference in implementing between the two. So Raspberry Pi connect an I2S microphone, and hopefully yeah, there we go. Then how are you reading the sound? Ah, I see. I have to them as well. Sense, that makes sense. Connect them like this. Left right clock. Oh, beautiful. Oh, okay. I like it when the pin names are descriptive, like left right clock. It's always nice. Okay, that's not too bad then. That is not too bad at all. We do have a backup config then, which is nice. I shouldn't go into it yet though, because there is still a long way before we get to the microphones. However, I should order them right now, because we will need them when the time comes. Ah, fuck my finances. It's fine. Anyway, I think that might be it for today's live stream, because like ever since we've connected the speaker, you probably were able to tell that I kind of lost my spirit a bit, because I didn't really plan anything else for the stream. This was the thing. This was the thing we were supposed to do. We did it on the very beginning of the stream. Why are we still going? We've won. We've beaten the thing. So I suppose that's gonna be it for now. I'm going to go work on the videos, and then if I have something else that would be fun to stream, fun to show you, then I'll do a second stream today. And for now, that'll be it. Thank you everyone so much for watching, and have a great day. Bye.